I'll just pop it on my desk. Alright. Let's begin. What kind of question is that? Oh, with help.
Yeah.
Yes. Can I teach first and then I'll help you?
Yep.
I thought you meant as in you wanted to help.
No.
Right. I'm like, what do you mean? Alright, let's begin. Ex2GH. Linear models. Boys. Talk again, I'll send you guys outside. Okay? Talk again, I'll send you guys outside. I gave you one instruction before. Do the quizzes. Write the solutions down. You guys were talking, and Ian, therefore, he didn't look at the solutions. I had up the answers. If you had looked at them, you'll be fine. So keep up. I don't want to be dragging you two with me. Okay? If you're not up for it, get out of my class and do your own thing. If you're going to come to my class, do something. Yeah? Alright, here we go. Ex2GH. Linear models. So, everything that you needed to learn was from 2A to 2E. That's where all the concepts are. All the quizzes I'm doing is just revising 2A to 2E. Okay, and if you're having troubles with that, it tells me where you're sitting at. Whether you've done 2A, whether you've done 2B, 2C, 2D, 2E, I will know from the quizzes. Okay? Afterwards, 2F, 2G, 2H is application. Okay, they're all application questions. So in this one here, as you can see, they don't give you an equation anymore. You are meant to figure out the equation. You are meant to read the question and say, well, what is my gradient? What's my y-intercept? You figure it out and answer the question appropriately. Yeah? 2H is going to be similar as well. So let's have a look at this one. 2G. Example 22, you've got Auscom's rates for local calls from private telephones consist of a quarterly rental fee of $50 plus 25 cents for every call. Okay, so it sounds a bit complicated there, but all they're saying is if you want to make a call, it's $50. The cost is $50 plus 25 cents for every call. So obviously the more calls you make, it'll be 25 times the number of calls you have. So 25 times the number of calls you make. So I'm going to call it N. Now what have I done wrong? So it sounds right. I said $50 plus 25 cents for every call. Where have I gone wrong? Meredith. It should be 0.25. Why is that, Lucy? Because it's cents, boys. Because it's cents, not dollars. See, the difference is when you're working with application questions, it has to make sense. If you say $50, you're adding on, this is now saying $25 per call. See, that doesn't make sense. What you have to say is 0.25, which means 25 cents, or 0.25 of a dollar. Okay, so 0.25 cents times N, which is the number of calls. And now it says construct a cost function that describes the quarterly telephone bill, which I have. Okay, so this is my cost. This is the money that you're going to pay if you're working, if you're with Auscom. Those are the rates, and this depends on how many calls you make. Okay. Now it says after you constructed an equation or a form or a function, the next part says sketch the linear graph. Okay. So now in this case here, we've got C equals to 50 plus 0.25 N. Now this is very similar to your y equals mx plus c. What is my gradient and what is my y-intercept? Can I please have, let's go with Lauren.
Yeah.
What's my gradient? 0.25, because you see, when you write y equals mx plus c, all you're really saying here is you're saying, whatever you're multiplying, what's the variable? Our variable is number of calls. Our y variable is our y-axis is the number of cost. Okay, so this is our cost. This is the variable depending on how many calls you make. Okay, so because of that, we can say, well, the value that's multiplied to the variable n is the same as saying m times x. Hence why I know 0.25 has to be my gradient. If 0.25 is my gradient, then the y-intercept has to be 50. Okay. Alternatively, you can sub n equals 0. If you made 0 calls, well, how much do you have to pay? Obviously that makes sense. If you made 0 calls, you wouldn't pay an extra 25 cents per call. You'd have to pay $50 flat out. Okay, so it's $50 to start off with, and then 25 cents for every call you make. So if you made 0 calls, it makes sense you start at $50. Okay? Now if you draw the graph, you got $50, so I'm going to do 50 up here, so that's a 50s here. So that's my y-axis intercept. This is cost. This is number of calls. Cost, number of calls, n. Now you need an x-axis intercept to sketch the graph. You need 2 points. You already got the first point. To get the second point, how do you do that? How do I find where it crosses the x-axis? Make y equal to 0. So in this case here, I'm going to find out, let cost equal to 0. So I want to know how many calls I'd have to make to see what would the cost be for it to equal to 0, right? So if c equals 0, I've got 0 equals to 50 plus 0.25 n, okay? Now if you work this out, minus 50 on both sides because that's a positive 50, negative 50 equals to 0.25 n. To find n, how do you remove the 0.25? What do you do? Divide. So if you divide negative 50 by 0.25, whoops, by I can't write there. I'm just going to move it over here. Negative 50 divided by 0.25, that will equal to n. Now 0.25 is a quarter. So you're really saying negative 50 divided by a quarter. What's negative 50 divided by a quarter? How do you do that? You can use a calculator. I know fraction sounds difficult, but all you're really doing here is you're saying negative 50 divided by 1/4. See how I'm writing it out? I'm trying to make it look easier by writing negative 50 divide, because that's what the symbol means. A quarter, remember you divide fractions, you just do the reciprocal. And that ends up being 4 over 1 multiplied to negative 50. Now what's negative 50 times 4? Negative 200. Now here's the question. If it's negative 200 might be about over here. If I draw my straight line, have I done it properly? No. What am I doing wrong? Because this is application questions. Felix. What am I doing wrong? What's wrong with the graph? I want you boys to pay attention. Phones away too. I solved it. I let c equal to 0 because that's what Ryan said before. I solved for n. N equals to negative 200, which is over here. What's wrong with the graph? I got my x-axis intercept. I got my y-axis intercept. What is wrong? Yes. You can't make negative calls. See, this is why I want you guys to pay attention. Because when you do your SAC and you ask me, I don't understand this or I get it wrong, it's on you, not me. I'm doing my best to teach you guys. It's whether you guys are listening or not. Yeah? Logically, if this is C represents the cost and N represents number of calls, how do you make negative 200 calls? That doesn't make sense. You can start off with 50. That's how much you pay if you made 0 calls. That makes sense. You make no calls, you pay $50 for whatever thing you go with. You can go with Telstra, you can go with Optus. It makes sense if you go with Ozcom. That Ozcom says, if you join us, it's $50. Any other calls you make afterwards is 25 cents afterwards. So it makes sense. It only is going to be more than 50. Minimum is 50. So when you sketch your graph, you shouldn't be sketching this. You should be sketching just that part. Okay? And that's what I mean. So when you're doing application questions, you just got to pay attention to what the variables represent. Okay? Oh, well, it's recorded, so if you had questions on that, you can watch that again. Yeah? But that's 2G. 2G is just application questions. You're just working with that. That's the only thing. Okay? Now, 2H. 2H. Can you please write this down? Exercise 2H. Simultaneous equations. I'm going to spend a bit of time explaining this. And I want you to understand the concept. Okay? 2H is the hardest one to understand. So please write these notes down. Simultaneous equations. Let's go. Now, Friday. Yeah. Here we go. Simultaneous equations. Let's say I give you. Let's say I give you these two. They're two linear equations. You got 6x plus 2y equals to 8. You got 9x minus 3y equals 15. Now, a lot of times back in year 9 and 10, you learnt elimination method and substitution method, and you solved it. That is what we're going to do today as well, but I'm not so much interested in the technique because you already know how to do it in year 9 and 10. What I'm more interested in is, what does it mean? So if I were to do this, and I were to work with you on it, I would say, let's do times this by 3, times this by 3, times this by 3, times this by 2, times this by 2, times this by 2. Why? Because I want to make the y values equivalent. Okay? Yeah, I want them the same. So 2 times 3 will give me 6. 3 times 2 will give me 6. So what you can see is I can get 18x plus 6y is equal to 24. So I'm just multiplying all the first line by 3. Then I multiply everything in the second line by 2. So this will give me now 18x minus 6y equals to 30. Then you do your elimination method. You say, add, subtract, multiply. So in this case, I can say add them because I know positive 6y add with an extra minus 6y will cancel out. So this is going to give me 0y, and this will give me 36x equals to 54. Then you say, well, that's equal to 36x equals to 54, and x will then equal to 54 on 36. Simplifying this down, what number goes into 54 and 36? 9. How many 9s in 54?
6.
How many 9s in 36? 4. We can simplify this further. 3 over 2, so it's 1.5. Yeah, but leave it as fractions, unless I ask you. Now, when you find x, what does that mean? See, we can do the technique, but I'm interested in what does that x represent? You can? So if I substitute, let's say, I got 6x plus 2y equals 8. I can substitute 3 over 2. X equals 3 on 2. And what you get is 6 times 3 over 2 plus 2y equals 8. What's 6 times 3 on 2?
So just try to find x.
Not 6. 9. 6 divided by 2 is 3. 3 times 3 is 9. Plus 2y equals to 8. Subtract 9 on both sides. 2y equals to negative 1. Therefore, y is equal to negative half. What's the point of all this? So you learnt this in year 9 and 10. What's it for? So I got x, I got y. What is this representing? It means nothing if you're just getting an answer, you don't know what it is. What is this x and y representing?
The intercept of 2 lines.
The intercept of 2 lines. And this is what Ex2GH gets tricky. Because all you have to understand is you got 2 straight lines. Now if you think about 2 straight lines, this is the problem here. If you're sketching 2 straight lines, there's only one intersection you can have. I'm going to do another color so you can see. If I do in blue, doesn't matter any 2 straight lines, there's only 3 scenarios you're going to get. You either get them crossing, so they have an intersection. If they have an intersection, that's what you're solving for. Elimination method, all you were doing was you were saying, what happens if x or y equals to each other? That's all you're doing here. What if they equal to each other? You find out this is where they equal to each other. So that's why it's the intersection point. This one here. 2 straight lines. So these are my 2 straight lines. Where they intersect. Intersect means where they have the same coordinate. So when you do this method, this x and y is the x and y coordinate of the intersection. That's all you're doing. Yeah? There's 2 lines. Yeah. And that's all you're doing. Simultaneous equations is the intersecting of 2 lines. Yeah? Now, as I said there are 3 scenarios. You can have 2 lines either cross, or you have 2 lines that never cross. So they're parallel. Yeah? They're parallel, or the third scenario, they're exactly the same lines. So you only got 3 scenarios here with 2 straight lines. You either intersect or you don't. So this is you don't. And this is you do. So there's only 1 intersection. This has 0 intersections. How many intersections would you have if it's exactly the same line?
Probably 0. What's flat?
Yeah, it's just exactly the same line. How many intersections would you have?
Or you'd have 1 y or x.
0. 1.
0 is when you're parallel. Parallel means that you never intersect.
Infinite.
Infinite.
Infinite instances.
So in your questions, if you think about it, if I draw a straight line like this, all right, think about that. And imagine if I drew a second line that's exactly the same. I'll intersect it 1, 2, 3, 4, 5 infinitely
Oh, right.
many times. Yeah? Whereas if I draw a line, if I drew a line and I drew a second line, see that crosses once. So we say it has a unique solution. Okay, so this is called unique solution because you only cross once. Whereas if you had 2 lines that are parallel, it makes sense that this is no solution. You have no solutions. Does that make sense? There's only 3 scenarios here. You can either cross, unique solution, 1, parallel, no solutions, or you have infinite solutions because they cross on every single point. Yeah? Now, if you understand that concept, all you're doing in exercise 2H is you're trying to find values where you do intersect, or you don't intersect, or you intersect infinitely. That's why it gets tricky. But if you understand it as just 2 straight lines, when do they intersect? It's when they don't have the same gradient. When do they not intersect? It's when they're parallel. Parallel means that they have the same gradient but different y-intercept. Okay? And then how do you have infinite solutions if they're the same equation? Same y-intercept, same gradient. Okay, I'm going to write that as a summary in case you sort of confuse what I'm saying. Scenario 1. Unique solution. This is unique solution. They cross once. How does that happen? They don't have the same gradients because they have different slants. Eventually you're going to intersect. True? Different gradients, doesn't matter what y-intercept. Y-intercept could be the same, but they have different gradients. Okay, so C doesn't matter. Doesn't matter. Okay, that's first scenario. You can write this down as your notes for exercise 2H. Yeah? Scenario 2. You won't have a solution or you won't have an intersection if they're parallel. It makes sense. 2 lines won't have an answer if they're parallel. An example would be 3x, y equals 3x, and y equals 3x plus 1. If I ask you to solve for that now, using elimination method, you're not going to get an answer. See, if you tried minusing both of them, minus, you see you get 0 equals to 0 plus 1.
So it equals 1.
Well, that doesn't make sense because on the left-hand side you say 0 equals to 1.
So 0 equals
Doesn't make sense. That's why no solutions. Yeah, that's why it's parallel. So you can't solve this one. That's why you can't solve it, okay? So here we go. This is called no... That's my point. Okay, so no solution. When you have no solution... Oh, sorry, I should do that. M1 equals M2. C1 can't equal to C2. Okay, because they have to have a different y-intercept. They have to have the same gradient, same slant, but they don't have to cross the same y-axis point. So if I draw 2 lines right now, so let's say it crosses 3, okay, it has a gradient of 1. To draw a parallel line, I have to make sure it crosses someone else, so maybe like 5. Okay, so it wouldn't cross at the same y-intercept. So different y-intercept, same gradient. That's when you have 2 parallel lines, no solution. How do you have the third scenario where you have infinitely many solutions? That makes sense that you have to have the same gradient and the same y-intercept. They're exactly the same line. So if you have the same gradient, same y-intercept, of course you're going to get infinitely many solutions. Yeah? So here we go. We're going to have, I'm going to write it here, infinitely many solutions. That's the only thing you have to understand from 2H. M1 equals M2, C1 equals to C2. Unique solutions when gradients don't equal to each other, and it doesn't matter whether this does equal or it doesn't. Okay? M1 equals M2, M1 equals M2 here. gradients equal. So if the gradients are the same. So if you have, like, for example here, I'll do an example so you understand. Y equals 3x plus 1. Y equals 2x minus 1. They have different gradients. They're likely to intersect. Because one, like, you know, if you draw out the line, this would be 2x minus 1, and the other one's 3x plus 1, so it has to be something like that. They have to intersect. They have different gradients. True? Yeah? Whereas if they're parallel, they have to have the same gradient to be parallel. But if they're parallel, there's no intersection. So hence, no solution. C1 means like the y-intercept of the first equation. Y-intercept. Remember, y equals mx plus c? C is the y-intercept. Yeah? So y-intercept doesn't equal. Yeah? This one, y-intercept equals, gradient equals. Alright? So that's your notes for exercise 2H. Only 3 scenarios that you need to understand. And now when you're answering the questions, that's all you're doing. Some of the questions, like if I move to the next one, you see they'll say the lines, this line and this line intersect at this point. So you know they have one unique solution. If you look at the next question, see the 3 different scenarios? They're asking, what would the values have to be to have no solution? Infinitely many solutions, a unique solution. Okay? And your job is to understand, well, the gradients have to be the same for you to have either no solution or infinitely many. Okay, so it all goes back to this one thing that I wrote here. All these notes here will help you understand how to do that question. Okay, so I'm going to do that question so it's recorded so you can watch that again, yeah? So that's 2H. We'll do it again tomorrow as well. 2H is the hardest one to understand. I do want you to take your time to understand it. But you can't do 2H if you can't do 2A to E. Okay, if you don't know how to read gradients, you don't know what a y-intercept is, then there's no point doing 2H because you won't get it. Okay, so here we go. Let's do this one. It has 3 scenarios in it, yeah? So it says, consider simultaneous linear equations. You got first line, you got another line. So there's 2 lines. Now we don't know whether these 2 lines are going to intersect or not because it depends on what M and K is. Okay, we don't know what M and K is. Now find the values of M and K such that the system of equations has no solution. Now I'll go through your notes again. You just copied my notes. How do you not have any solutions? What scenario would you not have solutions?
If it's 0 equals 1.
Yes, the 0 equals 1. How do you have 0 equals 1? How do you not have an intersection? 2 lines, how do they not intersect? When they're parallel. That's the only case logically. 2 lines, if they're parallel, they're not going to intersect. So, if they're parallel, it means they have to have the same gradient. They have to have the same gradient, but different y-intercept. That's the only way. I'm going to write here parallel. That's what parallel means. So it goes back to exercise 2E. That's what I meant. Perpendicular and parallel, what a straight line is, you had to know 2A to 2E. You get those foundation, everything else is easy. Yeah? So here we go. We're answering the question. If it has to have the same gradient, well, the first question is, what is the gradient of the first line and the second line? Now, the only way to do that, rearrange this. Okay, rearrange this to y equals mx plus c. You rearrange both of them, then you can tell what the gradient is and what the y-intercept is. The only reason why this is tricky is because there's so many different letters and students go, oh, I can't do it. There are too many letters, but it isn't. It's the same thing. This is your gradient here, multiplied to x plus y equals 2. Rearrange it. Make y the subject. Yeah? So I'll do the first one here. You got m minus 2 multiplied to x plus y equals 2. If I want to rearrange this so I get y by itself, I need to remove this. Okay, now you can see here that's all together. That's one group. Now that's a positive number right now. There's no negatives here. So what I'm going to do is I'm going to minus it and I'm going to bring it over here. So what you get is get y equals to 2 minus bracket m minus 2x. Now you got your gradient and you got your y-intercept. Okay, now I'm going to finish recording this tonight. I'm going to upload it, but 2H will do it tomorrow again. Okay, please work 2A to E. Just work on that for me.
Thank you, sir.
Okay, if you don't do that, you'll find it very difficult to do. Sorry? Yeah, I'll do this tonight and I'll upload it. Okay? To be continued. To be continued.